Okay, we're here at the 2024 Modelrama, and one of the things that we're seeing change in the hobby is 3D printing. There's probably 5 or 6 3D printers in the show right now, and I've actually been thinking about trying to promote it to more serious 3D printer hobbyists as to be a part of the show, because it is an important part of the hobby. And what's your name and where are you from?
Michael Ball. I came down from Detroit, Michigan, actually, for the show. My dad and I, we come down to the show. It's an annual event for us. It's really for us. We're both hobby guys. He's more of an airplane guy. I kind of dabble in the cars and competitively race the model boats.
Right.
I'm part of the IMPBA organization for the International Model Powerboat Association.
Okay.
That's our organization, similar to NAMBA, similar to the AMA. Yep.
Right.
For the flying. So I do support our organization as well.
Awesome.
But yeah, we come down here every year. It's a good excuse for us to get together, spend the weekend, and do some hobby stuff.
So you told me you were making parts.
Yep.
So tell me about your philosophy. What kind of parts you're replacing with 3D printed parts?
Yep, absolutely. So for me, my goal from 3D printing is how I transitioned. I'm actually my day job is a CAD modeler and a mechanical designer. So I transitioned very easily to the creating my own components. And that was my goal with 3D printing, and that was generating my own components. Where I find a huge advantage is for us builders is a lot of ability to make fixtures, anything to help us with our building process, more accurate building using the 3D printer. I have also started producing parts in small batches to help support our my boating guys. So what I have here, the example I have here, is a small motor mount. So we run nitro motors, and this is a floor mount, so this will bolt directly through the bottom of the hull. And then as you can see, if they're properly spaced, I've got the 4 mounting lugs for my nitro motors, anywhere from a 12 size motor all the way up to what we would call a 90 or an F size motor.
So obviously if you're mounting a glow motor, that's got a lot of power, a lot of vibration. The other thing we have is chemical compatibility.
Absolutely.
So what kind of materials are you using for that?
Yeah, so I exclusively use what they call the PETG materials.
And so that's what we're looking at?
Yes, sir, yeah. So this is PETG. Now what I found is the reason why we've chosen PETG over a PLA, which is far more popular right now with kind of the trinkets and kind of the beginner material, is the PLA is much more brittle after printed. PETG offers a little bit more mechanical elasticity, as we like to say in our industry. So a little bit more give and take, so to speak.
Right.
And then also, hopefully, as I transition through my experience on 3D printing, we'll develop an enclosure, so we have an enclosed environment to manage the ambient temperatures.
Right.
And then we'll start moving into ultimately PC or polycarbonate, which is effectively nylon.
Right.
Yep. But a lot more difficult to print.
Right.
Yep.
Yeah, you definitely need a heated chamber for that.
Yes, absolutely.
Yeah, and like one of the other things I've encountered, I'm also a 3D printer, is PLA melts very easily.
Yep.
So you wouldn't want to leave PLA parts in your trailer. You really can't leave them in the sun outside.
Nope.
So, but on an open printer like this, you can print PETG.
Yes, you can. Yep.
Which is fine outside.
Yep.
But don't let anybody dissuade you to think that 3D printed stuff is cheap and cheesy. It's not. It's really high tech.
Yep.
You just got to pick the materials correct for the application.
Absolutely.
And it's not all that hard to learn to do. There are some difficult materials, but PETG is not a difficult material.
No, I'd say PETG, right? It's with a little bit of investment, a little bit of time, it's not all that difficult. Like you had already mentioned, you don't have to go through the process of an enclosure, and although all the materials are fairly temperature sensitive to the ambient temperatures, but yeah, you can successfully print PETG very easy.
And what's the role of that cost?
So anywhere from, depending on where you want to shop, I would say anywhere from $18. Probably some places are selling it close to 20, but you're talking about what they sell it is a 2.2 kilogram roll, which is effectively a pound.
It's 1 kilogram.
1 kilogram. 2.2 pounds. Right. Thank you. Yeah.
So 2.2 pounds is a lot of plastic.
Absolutely.
Yeah, and it's really relatively cheap. I'll design a part. I think it's perfect. I've printed the part. I look at the part and I go, oh, I should have put a fillet there.
Yep.
I didn't think that I needed a notch here or whatever. I can pitch that in the trash can and make the corrections and print another part.
Yep.
So.
And you're only putting pennies in the trash can, right?
Right.
You know, some other common uses is using the print as a positive to build out molds for fiberglass molds.
Right.
You know, that's a really good application. Like I said, personally, I like to use it for jigs, fixtures, building. You know, just little tools that you want, and then of course, you know, actual functional components are always great too.
So I've got an application at work where I need to build a special fuel can for gasoline, a fuel cell for gasoline. You said positive molds, so you're glassing over the mold, over the part, and then how are you removing the plastic?
So you can, right, if you want to get really fancy, you can overmold something, and if you leave leave an opening, you know, you can go through and melt that plastic and dump it out. Now it's, you know, you make sure you're using proper PPE, personal protection equipment, but some of the solvents will break down, in particular acetone, will start to break down the PETG or even the PLA, and that allows you to then have, you know, you've overmolded something there, right?
And that doesn't affect the epoxy?
No, as long as you're using a two-part epoxy. I traditionally use a marine-based epoxy for all of our work because it's universal across all my building. We found good results with that. You know, you just want to have a couple really good layers to make sure that whatever you're overmolding is strong enough, and we've had great success with that.
So when we buy a set of like Bob Smith 5-minute or 15-minute epoxy, or what's the other one? Hobby epoxy finishing resin, which is thinner.
Yep.
Are these polyester resins or epoxy resins, and does that matter when you're going to use acetone to melt out something?
Yeah, so that's a good question that I may not have the best answer for.
Well, I'm not sure. That's why I asked. I thought you might know.
Based on practical experience, right, I'm using full epoxy resins. I've not used any polyester resins. So, you know, for practical experience with me, I've used a product called West Systems.
Very popular.
Yep, very popular. It's a very good marine-based, high-quality epoxy resin. So I use that exclusively when I'm doing those types of projects because I know that the quality is there. I know it's an overnight. It's not a quick curing epoxy. So I find that those tend to be a little bit more resilient to activities and functions like we're talking about here.
So another thing that's kind of adjacent to what we're talking about is one of the things that is a problem to be outdoors with PLA can be a feature in the sense that they'll make sand casting molds out of PLA, and they do this process called lost PLA casting. And so they make their positive mold of what, or the positive thing that they want to cast. They'll pack the sand around it. They heat that up above, probably once it gets about 160, 170, it all runs out like water.
Yep.
And then they can pour the molten metal in.
That's right.
So I wonder if that technique could work with glass, with fiberglass projects.
Yeah, that's an interesting idea as well.
Rig your part up with the hole down in the oven.
Yep. Yeah, that's a good idea that I hadn't even thought of, because even some of the gentlemen that are really good with composites have used that same idea and thought process for carbon fiber tuned pipes.
Yes.
Yep. And so they're using a high temp epoxy, a very purposeful epoxy, to then, you know, do their molding of carbon fiber tuned pipes.
Right.
So yeah, there's definitely higher temp or higher two-part epoxies that can allow you that you could withstand the heat, right? That you're going to induce in order to get rid of that mold. But that's a good idea too.
So is the state of the art now, if you want a tuned pipe, you have to make it?
Well, you know, as far as our, you know, the model boats are such a small portion of our hobby, you know, compared to the airplanes and such, and we're very performance driven, right? You know, certainly there's aspects of control line racing in airplanes where there's more performance than there is kind of leisure activities associated to, but for the most part, right, the portion I'm involved with, it's highly competitive, and there is definitely mechanical science to tune pipe shapes, lengths. So you know, like anybody in the hobby, regardless of the discipline that you like, cars, boats, planes, whatever, right? All of us like to tinker. There's kind of always that common theme of us trying to kind of be able to tinker and really enjoy and kind of the true definition of being a hobbyist, right?
Right.
Tinkering around. Sometimes that stuff works, sometimes it doesn't.
Yeah.
So.
But you learn along the way.
Absolutely, yeah. I mean, in my case, right, while my day job is mechanical design, I'm not a machinist, but I've got some machine tools at home, right?
Right.
So this is a great example.
This is a machine tool.
Right? It's a machine tool, absolutely.
Yeah.
So even in my industry, right, we're really transitioning into what they call MBD or model-based design, where we're taking the CAD models that you're using to design items, and you're no longer using a paper drawing.
Right.
You're taking that CAD model and that information, you're embedding all of the information into that, all the engineering information and design information, and that goes through what they call a digital thread, and you have what they call derived elements from that CAD model, and this is a derived element, right? I'm taking that CAD model and it's being made directly off the CAD model. You don't have a separate piece of paper of an engineering drawing that people are making things off the paper. They're truly making it off the CAD model, and that's what all this stuff is.
But there's like lots of simple software. I use Tinkercad for some of my products, which is basically software for children, right?
Yep.
But you can make some complex items with that.
Yep.
And this is very accessible. You don't need a degree. You don't need to know how to use SolidWorks, which is very difficult. I've played with that. And you can make the parts and pieces that you need.
Yep.
And this is an excellent example. When you get out to these events, you can meet people that are very, very knowledgeable and can help you along and learn things. That's an important element of why you want to go to these trade shows and these bigger swap meets in our hobby.
Absolutely.
You never know who you're going to encounter.
Absolutely. Just to pull on that for a minute, right? And I think it's a good comment is you talk about accessibility, right?
Right.
There are, if your desire is to print things and you want to design your own things, there's Tinkercad that's free. It's available out there. Another one is called Fusion 360, which is very popular. And then another one is not Tinkercad. There's one other one I'm drawing a blank on. But the point is with a little creative internet searching, you'll find some solid modeling softwares out there that are free. And then on top of that, there's a long list of YouTube videos that train you and give you information on how to use the tool. So it's there. It's all about applying yourself and getting involved. But like you said, it's 100% accessible.
Yeah, and you think of 3D printing as something to make your Mandalorian helmet or your cosplay gear, or models to paint, but like he and I are kindred spirits in the sense that we make mechanical objects.
Yep, that's right.
I like functional things that do stuff, and that's how I see it. I'm not making something pretty. I'm making something functional.
Functional, right? But you're absolutely right. I mean, the opportunity you have with the 3D printing can spans a wide range of capabilities to fit what you want to do with it, right? If it is maybe just little parts and pieces, lots of people make chess sets with it. And then they'll even start getting into what this is. It's still boxed up, but that's a resin printer. So that's a liquid resin printer, and it's a little bit different function, but they have their disadvantages and advantages for sure. But it covers everything, right?
All right. Well, hey, thank you very much. We appreciate you coming to the show.
Appreciate you guys putting on the show.
Yeah, we hope you come back. So.
All right, great. Thanks,
Thank
Dave.
you.